Now we've learned about atoms and molecules and elements and compounds, and what you are actually going to find is that in nature, in most things, what we have are mixtures. And so today we're going to talk about mixtures, how we can separate mixtures, and then how we classify different kinds of mixtures. You can find this in section 3.6 in your notes and the beginning of 3.7. A mixture is a combination of two or more substances in which each substance retains its properties. So it's when you mix two things together, but neither of them change their chemical or physical properties as a result of being mixed together. So what's the difference between a compound, which is actually a pure substance, not a mixture, and a mixture? So what we have here are just a particle diagram of each different type. And so you can see that for a pure substance, that is a compound, each one of these represents one compound. So there are lots of them, and they all have one yellow and one blue, but they're all exactly the same. So we really still only have one type of substance in here. It's just this blue and yellow compound. Whereas on the right here, we have a combination of blues and yellows that are not bonded to each other. So we have both blue atoms and yellow atoms. So we have two different elements present in this mixture. Because in a mixture our substances retain their properties, we can actually separate them based on their physical properties without changing them. So for example, if a substance is magnetic, it doesn't matter if you mix it with other things, it's still magnetic. So I'm going to talk about two different techniques that maybe you haven't heard of that you can use to separate mixtures by physical means or based on their physical properties. The first one I'm going to talk about is filtration. And filtration is a method that you can use to separate a solid and a liquid when they're in a container together. So you probably do this most mornings, or your mom or dad do, when you make coffee. So the coffee grounds go in the coffee filter, and you run water through it, and the soluble part of the coffee comes through, and the solid grounds stay in the filter. So that's just a really simple way to separate things based on the size of the particles. So solids have large particles, and the molecules in solutions are much smaller. The last method I'm going to talk about for separating mixtures is called distillation. And distillation takes advantage of the fact that different substances have different properties in terms of their melting point and their boiling point. So if you remember, the melting point is the temperature that a substance goes from a solid to a liquid, and the boiling point is the temperature at which it goes from a liquid to a gas. So when we have a distillation apparatus, which is what I've shown here, in this section right here is where we have the mixture that we're trying to separate. And you heat that mixture until one of them starts to boil. So the one with the lower boiling point will boil first, which means it will turn into a gas, and it will come up here and run down this tube. Right? And as it gets down to this part here, this is where there's cold water running through, and so it will cool off pretty quickly and we'll get condensation. And so once it condenses, it will run downhill and into this collection flask down at the bottom. All right, so the thing that boils first will come off first, and we'll get that separated. So you could use this to purify tap water, for example. So the water would boil, but the minerals and other things that might be in the water would stay in your flask up here and be separated from the water. All right, so this process is called distillation. Finally, I just want to touch briefly on the different types of mixtures, and you're going to have a video tomorrow that will go into this in more detail, but I just wanted to go over a couple of definitions. So a pure substance is by definition not a mixture. A pure substance only contains one thing, whereas an impure substance would be a mixture. This would contain at least two different things, which are mixed together, and so they're no longer pure. All right, there are two different types of mixtures. One is a homogeneous mixture, and in a homogeneous mixture, homo means the same, and so no matter where you look in your container, the material will be evenly distributed. So if you took a sample from the top or you took a sample from the bottom, you'd still get the same thing. All right, a heterogeneous mixture is one where the particles are not evenly mixed, and so in this case down here, if we took a sample from the bottom down here, we would get mostly green particles, but if we took one from the top up here, we would get mostly purple. Okay, and so this is a case of differences depending on where you look in the sample, and it's not evenly mixed, so that's heterogeneous. All right, so tomorrow we're going to look at different types of heterogeneous and homogeneous mixtures and where you can find some of them and some examples.